is Professor Vishwajit Ambade from Mechanical Engineering Department, and today we will discuss about the numericals based on the U-Tube Manometer. So this is the question which is written on blackboard. So I am reading the question and will draw the diagram according to the given data. A U-Tube manometer is used to measure the pressure of a water in a pipeline which is in excess of atmospheric pressure. So first of all, we will draw a U-Tube manometer. So this is the U-Tube manometer. Now the right limb of the manometer contains mercury and is open to atmosphere. So this is the right limb of the U-Tube manometer, which contains the mercury, on the right limb of the U-Tube manometer, and is open to atmosphere. It means that the right limb of the U-Tube manometer is open to atmosphere. The contact between water and the mercury is in the left limb. It means that this portion contains the water. This is the left limb of the U-Tube manometer, which contains the water. And in the left side of the U-Tube manometer, water and mercury comes in contact with each other. So this is the point. We can assume this is point B and C, where the water and the mercury comes in a contact with each other on the left portion of the U-Tube manometer. Now what again given? Determine the pressure of water in the main line if the difference in the level of mercury in the left limb of U-Tube manometer is 10 cm and the free surface of mercury is in level with the center of the pipe. This means the level of the U-Tube manometer in the right limb will be in line with the center of the pipe. If I assume this is the point A and this is the center of the left limb, so therefore the difference of the mercury level or the level of the mercury in the left limb is 10 centimeter. So this is the 10 centimeter. This is the distance of 10 centimeter, and this level must be lying on the center of the left limb. So this is the center of the left limb, and this distance from the datum line is 10 centimeter. So again this distance is also 10 centimeter, means the mercury level distance is again 10 centimeter and the height of water above the datum from the center of the pipe is again 10 centimeter. So this is the first case which is given. Now what next? If the pressure of the water in the line is reduced to 9810 Newton per meter square, calculate the new difference in the level of the mercury and sketch the arrangement in both the cases. So this is the case number 1. Okay. Now what in next case is given? If the pressure, whatever the pressure which is being acting on first case, that pressure is reduced up to 9810 Newton per meter square. From this it is clear that in the first case, whatever the pressure which is acting must be greater than 9810 Newton per meter square. So that we have to find what amount of pressure is acting on the first case, and in second case pressure at point A is given and we have to calculate the next difference in the mercury level. So we will see later on. So this is the diagram for first case. So what is given? the specific gravity of water, or we can say density of the water. This is the given data. Density of water, assume it as ρ1 is equals to 1000 kg per meter cube, and H1 height of water level, that is H1, again 10 centimeter converted into meter, that is 0.1 meter. Now density of Hg means mercury 13600 kg per meter cube, and again H2, this is ρ2, H2 is again same 10 centimeter, that is 0.1 meter. Now as we know that the pressure on left side is always equal to pressure on right side, therefore equating the pressure equation, on both side of the link, that is equating the pressure on left side of the link and equating the pressure on right side of the link. Therefore equation will be pressure at A plus ρ1 g H1 equals to ρ2 g H2. This is the equation for calculating the pressure. Now put the values in this equation. What is the equation? PA plus ρ1 g H1 is equals to ρ2 g H2. Now the pressure at point A is unknown, plus ρ1 density of the water 1000 into 9.81 into H is 0.1 is equals to ρ2 is 00 into 9.81 into 0.1. After putting the value, we will get the value of pressure at point A, that is 0.6 Newton per meter square. So this much amount of pressure is acting at point A for the first case. Now what is given in the next case? We have to reduce the pressure up to case 2. Pressure at A is 9810 Newton per meter square is given. We have to reduce this pressure up to this level. It means that for the second case, pressure at A is 9810 न्यूटन पर मीटर स्क्वायर. अगर ऐसा होता है तो इसका मतलब क्या होगा? यहाँ का जो प्रेशर है वो कम हो रहा है. इसका मतलब द लेवल ऑफ द मर्क्यूरी will down from right side and it will rise on the left side by somewhat distance. Therefore we will get the new level of the mercury. This is B star and this is C star. This is B star and this is C star. So we can assume that this much amount of mercury level will rise on the left side by the distance of x. तो जितना यहाँ से रिड्यूस होगा उतना ही अमाउंट ऑफ मर्क्यूरी लेफ्ट लिंक में क्या होगा? इंक्रीज होगा. So this is again x. If this is x, it means that this distance is again x. So what remains? So this is new level and this is new level. So this distance how much? ये जो distance रहेगा वो रहेगा 10 minus 2 times of x. 10 minus 2 times of x. So in that case, the distance of the mercury above the datum on the right side will be 10 minus 2x and this distance from the new datum line above the datum line on the left side of the link is 10 minus x. This much distance remains after the rising of the mercury on the left side. So this is the new case, new diagrammatic representation for the second case. So we have to again calculate the difference of the mercury level. So let x be the distance. Let x be the distance of the mercury level So now again equating the pressure equation on both sides. Therefore, what will be our equation? Same equation, rho A plus PA plus rho 1G H1 is equals to rho 2G H2. So this is equation number 2. Now what is given for case number 2? केस नंबर 2 के लिए क्या क्या गिवन दिया है? PA की वैल्यू इज प्रोवाइडेड 9810 न्यूटन पर मीटर स्क्वायर. H1 will be, this is the H1, 10 minus x. So this is in centimeter. To convert it into in meter, H1 will be 10 minus x upon 100. It is in meter because we are provided that 10 is in centimeter and we are taking all the units in meter. Therefore, we have to convert this into meter. Similarly, H2 will be 10 minus 2x is in centimeter. After converting, H2 is 10 minus 2x upon 100. This is in centimeter. This is in meter. Now after putting all this value in this equation, what remains? 9810 plus rho 1 is 1000 for the water into 9.81 into H1 is 10 minus x upon 100 equals to rho 2 is 13600 into 9.81 into H2. Then what is the value of H2? 10 minus 2x upon 100. Now after solving this, 9810 plus 9810 into 0.1 minus 0.01 times of x is equals to 13600 into 9.81 into 0.1 minus 0.02x. So after solving all this equation, we get the value of x, means this distance, we get the value of x. So value of x will be 0.992 meter, 992 centimeter. Therefore, new level of the mercury. New level of the mercury will be what? This is the level of the mercury. Level of the mercury is 10 minus 2x. So this is again in centimeter minus 2 into 0.992. 0.992. Then what we get? 8.016 centimeter. This is the new level of the mercury above the datum 9. So in this way we can find out